Hi everyone, we are group 19 and our topic is generalized correlations for liquids. First, a bit of history. The method began with Harold Reckitt in 1970, who developed an equation to estimate liquid volume. Then, in 1972, Charles F. Spencer and Robert P. Denner refined it, creating the modified Reckitt equation. Earlier in 1955, Lyderson, Greencorn and Haugen had also developed a model using corresponding states principle. Next, for the definition, these correlations are based on the generalized qubit equations of state, which give a high degree of precision in predicting liquid behavior. One common model is the Lee-Kessler correlation, which includes data for subcool liquids and works best for nonpolar and slightly polar fluids. And for fun facts, Reckitt's equation, even after 50 years, it's still used today in software like Aspen Plus and HYSYS. Robert P. Denner and Charles F. Spencer was also known for making thermodynamics easier to understand.
The Reckitt equation is an empirical form of the equation of state that relates the reduced volume of a liquid to its reduced temperature. Reckitt explained that there is no specific theoretical basis for the equation as it was derived purely from experimental data. He found that many liquid density correlation involve temperature terms and concluded that his proposed equation is more precise than other models, although some polar liquids did not conform. His study of 82 compounds later contributed to development of generalized correlation by Lyderson, Greencorn and Haugen.
Next, we have the equation for estimating the molar volume of a saturated liquid. This was proposed by Reckitt. This equation relates the saturation volume to the critical volume, compressibility factor, and reduced temperature. There is also an alternative form that includes reduced pressure. These parameters help us predict the liquid's behavior near its critical point. This equation estimates liquid volume using reduced density, which depends on reduced temperature and pressure. It was developed by Lyderson, Greencorn, and Haugen. The first equation defines reduced density, which compares a liquid's density to its critical point. The second equation allows us to find a new liquid volume V2 based on a known volume V1 and the ratio of reduced densities. This is example graph for this topic.
To substitute all the given data and apply the equation efficiently to find the required property. Here, we aim to determine the saturated liquid specific volume of acetone at 20 degrees Celsius. The data provided includes the critical temperature, critical pressure, and specific gravity of acetone. These values are used in the Reckitt equation to calculate the result. Next, all the values are substituted into the Reckitt equation using MATLAB. This equation helps us calculate the saturated liquid volume. After dividing by the molecular weight, we obtain the saturated liquid specific volume.
Now, to conclude, this method helps estimate liquid volume by using reduced density, temperature, and pressure. It also provides a reliable way to predict liquid properties when data is not available, simplifying calculations and improving design efficiency in chemical process.
So this is the reference that we are refer for this assignment, and thank you.